Let's continue our learning on the knowledge engineering. So in the last video, we have seen about basics of the knowledge engineering and the steps involved in it. And we have discussed about the if then else rules based knowledge information forming. And now in this video, let us discuss about the semantic rules. So basically, the semantic networks are a knowledge representation technique used in the knowledge engineering that represents the information in the form of the information knowledge in the form of an graphics. So in a semantic network, the nodes represent the concepts and the edges represents the relationship between the concepts. And this graphical representation makes it easier to visualize and understand the structure of knowledge within the domain. So let us explore this within an example where the domain considered is the animals and their characteristics. So now in this semantic network, the nodes represents the animals and their characteristics, and the edges represents the relationship between these concepts like the animals and their characteristics. So let us define the nodes as animals. The examples are a lion, tiger, and giraffe, and the characteristics like a carnivore, herbivore, fast, tall, etc. The edges, the relationship between the animals and their characteristics. For an example, the lion has the characteristics of carnivore, right? So this is how the nodes and edges are defined in the using the semantic rules, and you can see this how the knowledge base is provided. For an example, just you take for the node line, the possible edges are the lion is a carnivore, the lion is fast, the lion is feline, lion is a mammal, lion is a big cat. And if you take for the tiger, the characteristics, the mapped characteristics are the tiger is a carnivore and it is fast, feline, mammal, and it's a big cat. And when it comes to the giraffe, it's an herbivore and it's a tall and mammal are the characteristics that are mapped to the node giraffe. Now, the each node in the semantic network represents a concept such as an animal or an characteristics, and each edge represents the relationship between the concepts. For an example, the edge lion is in the arrow indicates carnivore, indicates the lion is a carnivore, right? The semantic networks can include various types of relations such as is a, as a, are a part of, are related to sort of relationship depending on the domain and the specific knowledge being represented, right? So and just for an taken example, you know that Dolo 650. So Dolo 650 is basically a drug which is used in for treating the pain, but basically it's a banned drug, right? So with respect to dollar 650, we have both the benefits and also harm, right? Accordingly, it is grouped. So while whenever I keep that dollar 650 as the input, I will map all the characteristics, right? In Indian pharma, it is allowed, but whereas in the other countries, the dollar 650, the usage of dollar 650 is not recommended. In some countries, it is completely banned, right? So it can have any sort of logic. So dolo is a tablet, right? It has a paracetamol in it, and it's a part of the drug which is used for used in the painkiller application, and it is mostly related to affecting the kidneys, and hence it is banned in certain countries. So like this, we'll compile so much of information about a particular node and then we'll relate it, right? Then if you take the semantic networks, it can be hierarchical with more general concepts at the higher level and the more specific concepts at the lower level, right? The semantic network will provide a flexible and intuitive way to represent and organize the knowledge, making it easier for the knowledge engineers and the domain experts to understand, analyze, and manipulate knowledge within the domain. So, as an overall, the semantic networks are the powerful knowledge representation tool in knowledge engineering, enabling the structured and intuitive representation of complex knowledge domains. Now, this can be discussed with an example of a simple online shopping recommendation system. So, the domain what we consider here is I want to search for an electronic product. Now, how in the semantic network it can be represented. So in this semantic network, the nodes represent the various entities such as the products, features, and the user preferences, while edges represents the relationship between these entities. For an example, the products can be like a smartphone, laptops, or vacuum cleaner, or I need some other gadgets. Let's say I need to procure one robotic vacuum cleaner. And what are the features I need here? It is based on the camera quality, battery life, and if when it comes to the vacuum cleaner, whether it can perform dry mop or only dry mop or wet mop, both kind of thing. And user preferences like the budget and the brand. So edges. So now, if I consider the smartphone, for smartphone, technically I'll consider the features like the camera quality, battery capacity, and the type of processor, network capabilities, and the preferences. Again, I'll keep whether I want to go for an brand standard brands, or I want to go for the new brands, or whether I want to prefer the mobile of my priority, the cost. Again, in the sense cost. So I just let me take an node. I'm defining for a smartphone A, and a smartphone A has a high camera quality. It has a long battery life, and it is of brand X, and it is of price $500. And similarly, if I take this smartphone B, I have this high camera quality. I'm mapping it with a fast processor, and it is from brand Y, and it is priced at $600. Say. And similarly for the laptop, I'm defining the laptop X is of large screen size, and it's having a longer battery life, and it is from brand X. It is priced from at $800. So like this, you can add a few any number of features to it, and it has been properly mapped. Right now, each node in the semantic network represents an entity relevant to the online shopping domain, such as a product, a feature, or a user preference. And the edge, which is nothing, which is indicated in the form of an arrow mark. Say it is going to specify the quality of of each and every node. And these semantic networks can capture various relationship between the products, features, and user preferences, enabling the personalized recommendation based on the user profiles and the product attributes. So by analyzing the semantic network, the recommendation system can identify products that matches the user's preference and provide the tailored recommendations accordingly. And the semantic networks allow for flexible representation and the manipulation of knowledge in the recommendation systems, facilitating an effective decision making and enhancing the user shopping experience. And the other part of this is your frames. The frames is another mode of knowledge representation technique used in AI-based system, okay, to organize and represent the knowledge in a very structured manner. The frames provide a way to represent objects, concepts, or entities by breaking them into smaller components or attributes. And each frame consists of slots that represent the properties or attributes of an object along with the values of those properties. Let us understand the concept of frames with an example. So let us create a framework for representing different cars. Let the frame name to be car, and in this frame we have several slots like the make, model, the year in which it was manufactured, color, the type of engine, price, and other safety features, etc. We'll keep all those things for every car and brand and kind of thing. So for car A, they make a Toyota, the model is Camry, and it is manufactured in the year 2021 and its color is red. The engine capacity is 2.5 liters and it is priced at $28,000. And you take another car B, which is a make of Honda model Civic, which is manufactured in the year 2018 and the color of blue, and its engine capacity is 1.8 liters and it is priced at $22,000. Right. So this how an information is represented in a by means of a frame. So the frames provide a structured way to represent the information about objects or concepts by organizing them into slots and values. So now in the each frame serve as a template for representing the instances of a particular concept or an object. So in this example, we considered the frames for different cars. And these frame instances represent the specific examples or the instances defined by the frame, right? So for an example, here in this case, for each and every car, we had all the parameters that are listed, which includes the make, model, year, the capacity, cost, and extra. And the frames allow for the representation of complex relationships and attributes of objects in a concise and structured manner, making it easier for the knowledge-based systems to process and manipulate the information. And it's a powerful knowledge representation tool used in various AI applications, including expert systems, natural language understanding, and intelligent tutoring systems, and among others. And they provide a flexible and intuitive way to organize and represent knowledge, enabling an effective reasoning and decision making in AI systems. Let us apply the frames with another by considering another example, so called the employee management system. So here in this frame representation, we'll consider the information related to the employee. And the first slot is about the employee's ID. Then we represent the name of the employee in the then department where he belongs to, and what is the position he is currently holding, what is his current salary drawn, from which date he is being hired, and who is the authority, who is to whom he is reporting, will be the manager or the supervisor, right? So now the employee frame serves as a template for representing the information about the individual employees in the company. So let us say I have 100 employees in my company. I'll have 100 such frames defined into it. And in addition to that, the basic information, I'll be having information related to the skill set also, the skill set of the individual employees, like hardware skill set, software skill set, and apart from this, managerial qualities, other entertainment questions, intelligent question, like that I can classify and I can provide more slots and more information onto it, right? And such frame instances represent the individual employees, with each instance having the specific values for the slots defined in the frame. Right. Just say for an example, an employee A represents an employee named John Doe who works in the engineering department as a software engineer and earns a salary of $80,000, was hired in January to 15, 2020 and reports to manager Jan Smith. So like this, we can define for n number of employees, and the structure, the framework remains same. You can have it like with respect to the students also. So I can have it like student X is taking up this particular course in this particular semester under a particular faculty, and during this class and during this course, this is his attendance percentage, this much classes are conducted, and this much number of classes he attended, hence so his attendance percentage. This is his cat 1 marks, cat 2 mark, assessment mark, this is a project he has done. Like this we can define this, and all these are common for all the entities defined that are present in that particular domain. So for an example, in our class, if there are totally 70 students, I can define 70 such frames with all parameters keyed into it, and I can create it as a a database. So whenever someone calls for what is the mark of a particular student, then I can key in the particular register number which is unique. With that I can map and I can take out all the information for him with respect to the particular course.